to talk about, among other things, scouting applications, methods, and you have a history with soccer.
Well, my company has a history with soccer, so to say.
So something that hockey can learn from football or from soccer.
Yeah, in some sense, I would say so, yes.
Great to have you here.
All right, thanks. Yeah, hi everyone. Yeah, we already said topic for the next 30 minutes will be how we can actually operationalize analytics for hockey clubs. And as an example, I will do this on the basis of a scouting application a club could build and models the club could incorporate in such an application. No. So let me start with saying some words about myself. So as I said before, I'm Robin. I am with D1, and within D1, I'm a consultant in the sports analytics team. My background actually is a bit different. I'm a theoretical particle physicist and obtained my PhD from University of Zurich 2 years ago. And afterwards, I joined D1 and have project experience mainly in the area of software development and data analysis in different industries. And yeah, why I'm here is because I'm part of the sports analytics team and I'm a big hockey fan. And I listed here my 3 favorite teams. Actually, one does not exist anymore. But okay, going from top to bottom, born in the city of Krefeld, currently playing in the 2nd division in Germany, but I'm a big supporter, try to see as many matches as possible. Then, yeah, Arizona Coyotes, not really there anymore. Perhaps my next favorite team will be from Utah then. And since I'm living for 6 years now in the city of Zurich, I'm also following the ZSC Lions and happy to see that they won the championship this season. About D1, so D1 is a European consulting firm. We have more than 1,500 employees. And my colleagues, they have a very similar background to what I have. So they are physicists, mathematicians, computer scientists. And all our projects usually have a very technological or analytical background, right? So mainly we are working on data analytics, data management, data security topics. And our main area of business is banking, insurance, and energy. But we also have these more innovative areas where our sports analytics team is in. Exactly. So now I think you know who I am, who I'm working with. So let's start. And I think it's nice to start with some motivation and actually remember ourselves that what's going on here, it matters, right? So I picked 3 examples, not from hockey, because I think we will hear a lot of success stories in the conference, but from other sports, where we see that data analytics really changed something. And the first example will be from the NBA. So I think you have heard about this a few years ago. Houston Rockets start to change the way they play basketball by realizing, well, if I go for more 3-point attempts, I actually score more, right? And these were insights they generated based on data. And by now, the whole league adapted to this way of playing. So here was really a game changer in this sense. Second example, looking into the area of American football. I mean, I think 10, 12 years ago, on the 4th down, you would always punt the ball, no? So no matter what, you would just punt the ball. But by now, there are models which shape to realize, okay, but there are situations where I should go for a run, right? Because this is more promising. Also here, analytics, a game changer in the way we play games. And then the last example, already going into the direction of scouting, is Brentford FC, Premier League club. Now, say twice in a row in the Premier League with a lower budget, and they really incorporated this Moneyball approach in their scouting. So they heavily rely on data-driven scouting. And these are 3 examples where we see that data analytics really matters. And with this motivation, now let me start going into the direction of scouting analytics. And I want to do this in a 2-fold approach. So first, I want to look into how can actually clubs operationalize data they have to their under their belt, right? So how can you perhaps combine data sources to gain additional insights? And then in the second part, I will then really do a deep dive into scouting models we were looking into and we were investigating. Now, if you think about data analytics in hockey, perhaps your situation, if you work with these sources, looks like this, right? So you have different data providers with different solutions, and they're doing a great job. So they give you insights. But at the same time, and we heard about this, using one application might not be good enough, right? There are situations, for example, thinking about scouting, you want to compare players from different leagues. We've heard this example before, where only looking at ice hockey data won't be good enough, right? Because they do not provide all the data. So there is basically some value add if you combine different data sources in a club-centric manner, right? So you will gain additional insights, and it will bring you into a situation where you can also add your own intelligence on top of these data by combining different data sources, and then use these data sources to also obtain a competitive advantage over other teams, right? Because if you just use the tools all the teams are using, right, then you cannot expect to be better than the other teams. So with this, I hope I could motivate you that thinking of a scouting application really tailored to one specific club is not a crazy idea, but it's actually a useful idea. And if you would then start to think, okay, how could such an application look like? You could think, okay, what are the features I would like to have in a scouting application? And then, I think we already touched this a bit. You want to have a huge database of player, right? You want to have players from different sources. You want to be able to really look, for as many players as possible. Then the second, perhaps the most critical part is, it's nice to have the data, but you want to have some intelligence within the application, right? So you ideally want to have self-developed models in there, which can help finding players which fits a specific profile or which you're looking at. And then already looking in the way how you visualize things, you want to have a nice player profile with nice charts which allows you to understand the style the players playing better. You might want to include some video sequences, right? Because we heard that this is relevant if you, you need to see the player playing to evaluate how good he is, right? Then, you want to be able to compare players from different league on the same footage, right? And there might be different data sources going into these comparisons. And then already thinking then ahead is, wait, perhaps it's good to have a shadow team, right? So if I have a player, let's think, okay, where in my lineup would he fit in? Where could we generate some chemistry between different player profiles? And then finally, you might also think, okay, my application could have extensions, for example, ChatGPT, right? So your scout is watching a match and needs to write a scouting report, and perhaps he just have to add some keywords, and then he would come up with a scouting report for a specific player. So I think these are features which could be in such an app, and also here it's important to note. if you start from scratch and you develop such a thing, you can really design this the way you want, and this could differ from club to club. And I'm just not telling you the story here, but we went basically through the story, not in hockey, but actually in soccer, with a big German soccer club, where we did this journey together with the club, where selecting the data you will need, right? Then adding intelligence into the app, and then building a really nice user interface. As you can see here, this is React-based for those of you who are a bit familiar with UI. So we went through this whole journey and gained some experience here, and I think we came up with a great result. Now, so what I think is interesting as well is, it's nice to see all these features, but it's also important to basically look under the surface, right? So what does this mean to build such an app? And basically, you can break this down in perhaps 3 parts. I divided it here in 3 parts. So the first part will be the data management part, then the fun part, the analytics part, why we are here, and then a user interface part. So starting here from the left, your scouting application most likely will have different data sources, right? So you could have data from Rice, Hockey Sports Logic. You connect the Elite Prospects API. You could have other data sources which will end up in your application. And then the first step would be to harmonize these data sources using a data lake, using a Postgres, a Snowflake database. So really utilizing modern cloud techniques here for data management. And then once you have your raw data process cleaned up, then really the fun part starts, where you could start then build your own intelligence in your application. So you can build your own scouting models for player evaluation, but also perspective rating, for example, right? How will player develop over time? So here then you will have the fun part. And then also, I think a very important part will be the user interface, right? Because you want to have a powerful, easy to use, appealing user interface, and a user interface which actually somehow aligns with the expectations of the stakeholders which will use the app in the end. Because, I mean, you can build basically the best model in the world. If you do not make it easy to use, nobody will use it, right? So it really depends also on how you display your results, how you make them accessible. So I think this is something which I would like to stress, that we should really, when we start building models, make it possible to use these models, right, in an easy manner, because otherwise we can build the fanciest model. If nobody uses the model, then I think this is a problem. Okay, so with this, I just want to give you a broad overview how this could look like. And I mean, during a coffee break, we could also dive into how such an architecture could look in the cloud using Microsoft Azure, AWS. Happy to talk about this. But yeah, since I already said that this is the fun part, let's dive into the analytics. And I think scouting analytics is a really broad topic, and I try to find 3 categories here, how you can basically divide this whole thing. So this would be player evaluation, then perspective scouting, and a third pillar would be league benchmarking. And basically, okay, starting with player evaluation, here the idea I think is clear. So you want to build models which predict specific KPIs you're interested in, right? So, and these can be very specific. So taking an example from soccer, which is perhaps not that popular in hockey, but thinking about packing, which was a big thing years ago in soccer, right? So how many players will I pass or I will cross by 1 pass, right? So you can define whatever basically you want and build your own logic here. And by doing this, you will be able to find specific players specific to a profile you're looking for. And also, obviously, this would then be the first step towards the Moneyball approach, right? To identify underrated players. Looking at perspective scouting, so perhaps this is not the first thing which comes to your mind when you think about scouting, but I think this is relevant. So how can you actually model the development of players? And also, can we actually identify what are the key drivers for young players to make it to the next youth teams, right? So from under 10 to under 15 to under 20. So what are the key drivers which makes players successful, or which are the drivers which makes them unsuccessful? And then perhaps adapt the way you train by gaining insights from data. So this would be part of perspective scouting. Certainly another area of perspective scouting could be that, and I think there's a lot going on, use data-supported decisions during entry drafts, for example. And then the last piece, league benchmarking, already touched on this in the discussion before. So there are situations where you will sign players from foreign leagues. And then you must be able to say, okay, this player, he scored 30 points in the SHL. Now he's going to Liga. So what does this mean? What can we expect from him? So be able to benchmark these leagues. And then obviously the application is that you would have a better understanding of the quality of the different leagues, perhaps the play style in the different leagues, and mitigate risks then when you sign players from different leagues. And the use case I'm now focusing on, I think it's part of league benchmarking and player evaluation, because what we were interested in was, okay, can we actually use data to find a new top scorer for a DL team? And why is this perhaps interesting? I mean, I think it's interesting for all the leagues, but one peculiar or one special thing perhaps about the German league is that if you look at the top scorers from the German league, they are mainly import players. And I think this is a bit different compared to the SHL or Liga. So at some point, you have to sign these players from a foreign league and get them into the DL, right? And then obviously the question is, how do you predict the performance of a player after he's transferring into the DL? And basically, this question you can then break down into two pieces. So the feature selection part and the data processing part. So feature selection, I think here it's easy because we said, I mean, we are looking for a top scorer. So what we want to predict are expected points per game in this case. And okay, what features will help us to predict this quantity? Certainly, the driver will be the points per game in the previous season, right? And there will be additional features which will contribute to this model, but this will certainly be one of the important ones. Then on the data processing part, what data should be used for our predictions? And there we went for a simple approach. So let's look at previous transfers in the DEL. And we took then the data from elite prospects. And after data cleaning, outlier removal, we end up with 1,806 events we were looking at. Okay, and then when you build such a model, and I think, I mean, all of you who did this before, you can agree. So you start simple, right? You start simple, you try to gain some first insights, and then you add complexity. And the same thing we did here. So this is basically league benchmarking what we did. So we want to predict the points per game in season T. Well, and how we do this, we have some conversion or equivalence factors, which depends on the league in season T and the league in season T-1. And this thing will be multiplied by the points per game in the previous season. And then you end up with your estimate for your points per game. And obviously, this is a very rough estimate, but it can help for a first overview. And these conversion factors, how we call them, how do you determine them? So what you basically do, you plot them here. So this is the points per game, for example, here for transfers from the AHL to the DL, how much the player scored in the AHL, then the points per game in the DL, and then you just fit a line here, right? And the slope of this line will give you the conversion factor. And you see, I mean, if I do this for the AHL, I end up with 1.2.3. If I do it from the DL2, which is obviously a weaker league, you end up with a smaller value, right? And then what you can do, you can just rank your leagues by these factors, and then you see as a consistency check, well, this is a reasonable ranking for leagues, right? So this basically a very easy model which you can do basically when scouting, just as a really quick check. What can we expect from these players? If I get a player from ECHL, okay, what does this mean? He scored 30 points there. So what does this mean for SHL? What does this mean for DL? Okay, so then let's improve on this model. What is one of the big shortcomings of this model is, I mean, no information about the previous team, right? So this is completely, the model is completely lacking this. And this we try to address here with our so-called log ratio lasso regression model. And the model basically you can see here, and this is now a bit for the math freaks who like to do some math, because the first question you would ask, okay, why? I mean, we want to predict points per game in season T, so why do we have this log of the ratio here? And the reason for this is, I mean, if you look at the data, or let's say, first of all, the target variable you want to predict in such models, it's always good to be normally distributed, right? And if you look only at the points per game in season T, this is not the case. But if you And you realize if you then look into the data that the ratio itself is log normal distributed. So if I take the log here, I have a nicely normally distributed random variable, which you can also see here. We have a nice distribution of the events. And okay, so this is just some math background to why we choose this variable here as our target variable. And then the feature which enter the model are the categorical feature, the league, one hot encoded. So from which league are we getting our player? And then basically addressing this lack of information about the previous team is this variable xz here, which is basically the contribution of the scoring of the player to the overall scoring of his team in the last season. So how much did he actually contributed to the success of the team? And with this, we incorporate some information about the strength of the team as well. And okay, then you have some first order interaction terms and then the typical lasso penalty term, which also helps to select relevant features. And then you validate your model, you check what are the errors, and then you see basically this model does better than the very easy one by up to 10%. Really depends a bit on the league, but we see some improvement here. And then also one thing which is nice with these easy models is you can really understand what are actually the important features, right? So what we show here is basically the feature, and this is the coefficient. And large coefficients means they contribute a lot to our model. And there you see the strongest contribution is really from the leagues. So this is a strong positive rate when we sign a player from the NHL, and a strong negative rate if we sign a player from the DL2. And then we also here, you see the contribution from this new variable, which you see is clearly non-zero. So yeah, this is the model we came up with and which we then used in our predictions. Now you can say, well, I mean, we are lacking so many information, right? So we could add so much more features. What about age, weight, height? What about time on ice? I don't care about points per game. I care about points per 10 minutes ice time. Or I want to incorporate power play and PK. And certainly, I mean, you can do all of this, but you have to keep in mind, while adding more and more features, you will need more and more data to train your model, right? And you really have to find some balance here. Same holds for using different models. You could also say lasso regression, not fancy enough. Let's go for boosted decision trees, go for generalized linear models where these whole story about normally distributed random variables is not relevant anymore. Yeah, you can do this. And we also investigated this. But also here, I think what is important to note is that the complexity of your model and the level of detail of your data, I mean, there should be some balance, right? And we use here simple data from elite prospects. And I think there we have a nice fit from our complexity the model has and the detail the data actually have. Now, I guess we want to see basically what is our model doing. So 3 examples here. One from last season. So remember, we are looking for top scorers for the DL. And actually, Grizzlies Wolfsburg, they managed to find one. Andy Mealy transferred from SHL with these scoring stats. 36 points in 51 games in the SHL, went to Wolfsburg. And our model, I mean, if you do the math, if you take into account how much he contributed to overall scoring of his team, you end up with 44 points if he plays all matches in the regular season. And it turns out, I mean, he was 8th best scorer in the league with 46 points, so rather close to our prediction. And then 2 transfers from this season, I think very interesting ones. First one, I'm not sure if everybody in the room knows him, Sabot Gedukes, used to play for the Eisbären Regensburg, champion of the DL2 last season, was one of the top scorers, really drive the success of this team and scored 71 points in 52 games. Now it's going to ERC Ingolstadt. Here, doing the math, our models predict that he will only score 15 points. But I think in any case, this is a good transfer because he has actually a German passport. So I think good job from Ingolstadt here. And then the most prominent one, Tobias Rieder, heading back home from the Lakers with these stats, is now playing for Munich next season. And our prediction for him are 43 points in the DEL. And with this, he will be among the, most likely among the 15th top scorer in the league. So perhaps he's this top scorer we were looking for. With this, let me conclude with just three sentences I want to say. So the first one is, and I think this is in line with what we heard before. So scouting remains a people business, so we cannot expect our model to do the job. But what it can help you with is a data-based second opinion, right? To challenge decisions you're doing. Then the second point is, I mean, if you really want to have a competitive advantage, there's no way around adding own logic, right? So come up with your own scouting models, because otherwise you use what everyone is using. And the last one is that, I mean, to facilitate an effective use of the model, it somehow must be embedded in kind of a data strategy, a club-specific data strategy, and could be good enough to, I mean, have a good repository with a nice Streamlit dashboard. For the beginning, this is perfectly fine, but you need to be able to somehow make it usable. And with this, let me just use 30 seconds of your time to talk a bit about other topics we are doing within the DeFi Sports Analytics team. So don't want to focus too much on the analytics part because I've talked about this, but we're also doing quite some work in match analysis, mainly in soccer, but currently we are also analyzing with a federation the data from the World Championship of last year, trying to gain some insights there. And we are always very interested in really innovative projects. I mean, in German, you would call them lighthouse projects, Leuchtturmprojekte, where you would really use cutting edge technology. And as an example, what you could think of, I think it's a hot topic currently, is the development of large language models tailored to the specific needs of clubs. Yeah, and with this, thanks for your attention and hope you enjoyed it.
If I'm a hockey club and I'm interested in this, how do I create a subscription per player? How do we create a relationship?
Between,
if I were a hockey club, I'm the president of a hockey club, and I want to use your product.
I mean, we as a company, we are always interested in work together with clubs, right? We are not selling this model, right? We want to develop something together and gain some insights there. And I think in innovative areas as hockey analytics, I mean, we are very open and so I think that's the easiest ways to reach out. And if these are topics which are relevant for clubs, we're always happy to kick something off here. And also, I mean, go beyond what we did here, right? So add even more insights, generate,
Interesting. It's going to be next year. We're going to put these names up and the players' rider and see if
we will look at it next year. Let's see.
Rob, when I saw this, I was like, yeah, we already know the answer. You only pick the best player, the best analysis, but now you put yourself out there.
I know.
For next year.
I mean, I have to be honest, right? I mean, there are predictions which are worse. Certainly, but I mean, he was actually the player which went to the and was then the top scorer, so I picked this one. But obviously, I mean, this is not proper backtesting, right? We did this, but this is a nice example to show, right?
Thank you.
Yeah, you're welcome.
Welcome. For the next